Hi everyone, so our previous tutorial taught you how to load a file using the CPC Snooper Analysis tool. Well, we're going to start the tool up again as we did previously, and this time I'm going to talk you through what the main window displays and the information that's available to you to use and diagnose faults with trains. So we've loaded up the tool as we did previously. Click on load and I get my file from yesterday. So we're on the 25th of August now, like I showed you previously, and we previously loaded the 24th file. So if I click on single step, I would load the first telegram, the first command telegram in the file, and we can see some information available to us here. So I'm quickly going to talk you through what each area on the tool shows you. Now, up at the top here, we've got the start and end time of the file and what the type it is, so verbc.obc file. Down here we've got the command telegram data. So with the VCC to VOBC polls, they work on a master-slave poll response type mechanism. So the VCC sends the command telegram and the VOBC responds to those telegrams. So we'll always get a command and then we should get a response that goes with it. We'll never get just a response on its own. So that's not how the command response mechanism works. So on this tool here, I'm circling the command telegram area with the pointer. Now we've got the time of the poll, the VCC, the channel that the VCC is broadcasting on, the direction, the SRC, and then also the time since the previous reply. So the specific information we've got related to the VOBCs in here, not decoded from the message header, are the vehicle ID, the type of command response. So there are type 0, type 1A and type 1B replies that we'll talk about in a second. This one is the normal, type 0, which is the standard train data. So we have a logical loop ID, which we're being broadcast on, target point for the train, the direction the VCC sees the train is moving in, the maximum train velocity that's permitted, and also a target velocity, which is sometimes included to help regulate the train speed. So we can see that's 70 kph here. The door enable status. So this isn't whether the doors are open or closed. This is whether the VCC has enabled the train to open the doors. And you can see here they're closed at the minute. Then when they're going to enable, this will say enabled. And we've also got the front and rear doors here for the front and end cutout on short platforms. So we've got also the active passive status of the VOBC. So this is where the VCC is commanding the VOBC to be active or passive. The auto state, so the VOBC knows whether it's permitted to go into ATO or whether it has to remain in PM. We've also got the EB status, so the VCC will always command the train to release the EB when it's safe to do so, or if it needs to EB the train, it can command here the train to EB. And then we've also got some coded command data that can be included within Telegram for you approaching the platform or other detailed information, pass-through messages as well for announcements to passengers, and this information can be shown up in these boxes here. The brake rate that the train must use for stopping, and then average gradient in the current area. And then also this is a very useful box. This isn't specifically one to look at here, but it can be looked at on the whole, is whether the last reply was valid or not. So this is very useful when we're assessing whether we've got issues with comms. And then here, in this area that I'm circulating, is the reply. So this is the reply to the type, to the command telegram. So it's saying I'm a type 0, I'm on actual loop ID, logical loop ID 1. This is my actual position, I'm going in the upward direction. And then here, these are calculated by the tool, the limited movement authority for the train, in meters and what that equates to in positions. So lots of 6.25 meters. When the train has to, or the VOBC has to report health codes, it has to do that through a special message called a type 1A or type 1B, depending on what the message is. And it does that by saying, yes, I would like to give you a type 1 reply, and the next message, the VCC will command a type 1 reply telegram, and the VOBC will respond with additional data, and we'll see that in future tutorials. We've got the actual velocity, the door interlock status, so as soon as you lose one door, you'll lose the vehicle door status. Indication to the VCC, train integrity for the round train circuit, active or passive state of the VOBC, what operating mode it's in, the emergency brake status. So these can be on even if they're not commanded by the VCC. There might be a train-borne reason for why they're on. The cyclic redundancy check calculation for the telegram, and the tools calculated CLC for what that should be, so we can see if they match. If they don't match, it's like there's some corruption somewhere in the comms path and the message has been corrupted. And down here we have derived information, and we'll see that get populated as we step through, but it will give us derived count directions, correlations, and also the orientations of the master and slave status of the two VOBCs on the train, and also the antenna position in relation to loop boundaries. It's important to note that the actual position reported here is the antenna position and not the front of the train. On the far right here we have filter options, so the file, as we step through it, will have command and responses from all different VOBCs on the railway. It's rare that we'd want to look at them all, so we can filter by just a specific train. So if it's just a specific VOBC, sorry. So if I select to filter on 8 and VOBC 4, add here, I will just get command and responses from 8 and 4. If you see those flick up here, whereas if I take that off, we get all the VOBCs on the railway. So that can help us narrow down our investigation to one specific VOBC or one specific train. We can also choose to ignore filler and search polls, because it's not just VOBC command polls. And turn on ignore command polls, we can step through. You can see filler telegrams, what VCC channel and loop that they're coming from, and if we don't turn on filter out filler polls, they will be predominantly a lot of the messages that we're seeing. So when I turn on ignore filler polls and step through, we just see polls with 1022 and 1023 in the vehicle ID, and these are the search polls from specific loops. So we can see them being broadcast in specific loops and specific VCCs for the entry locations on the railway. So we can turn off to ignore those as well, and that automatically puts our command polls back on, and we can go back to searching on vehicle IDs again. So most of the time when we're using this tool, we're going to specifically want to look at specific command and response polls. So that's single stepping through and how we can filter on vehicle ID, but we can also right click and select on VCCs to look at specific VCCs, and we right click on this box here, and we can also enter loop numbers. Left click on add there, and then all of a sudden we only get command and response messages off that one specific loop. As the train comes onto it, we get a number of empty replies before it starts replying properly on that loop. And there we ID 37 is on loop VCC 3, loop 11 at this point. Just single step through. Now we can also auto step by clicking on this box here, and you can see we quickly step through a lot of the telegrams, so that's a way to speed up running through the file. We can slow that down by increasing the delay between the steps. So this is stepping, but it happens a lot more slowly now. So we can view what's going on a little easier. We can also select go to time by entering a time in here and clicking on the go to value, and we jump to that point in the file. So that's how we can navigate around and use the Snooper tool, and those are the general areas and information that we're showing. Later tutorials will talk about additional features with the tool, real-time graphs, and how to look at specific trains, but that's the general navigation. Thanks very much.